Welcome to tonight's video on class number 18. We'll talk about two types of interest, simple and compound interest. All right, simple interest is when you're just drawing interest on the initial deposit amount, the principal. That's simple interest. So for example here, if you deposit $100 into an account that earns 10% annual interest rate, then you'll get paid once at the end of each year, and the interest is only paid on the initial deposit amount. That is simple interest. So how much money would you have in your account after 1 month? Well, after 1 month, you would still have $100 because there would be no interest. After 2 months, you would still have $100 because there's no interest. It's not until 12 months that you get interest, because you take $100 and you take 10% of that, and that's the amount of interest you get. So adding that to $100 would be $110. And 24 months, you take the $110 that you have plus another 10% of 100, multiply that by 2 because you've done it twice now, and that's where you'll have $120 of interest. Now, instead of doing that out all the time, you have a formula where you can say T equals P that should be a parenthesis, times 1 plus R to the small t, where T is equal to the amount in the account, P is equal to the principal, that's the initial investment, R is equal to the interest rate, and T is equal to the number of years. So if you did it for this problem for 24 months, which is 2 years, you would say T equals 100 times 1 plus, the interest rate is 10%, so 0.10 times 2 years. So it's equal to 100 times 1.2, which gives you $120. So that's an easier way to do simple interest problems. But remember, simple interest is when the interest is only paid on the initial deposit, on the principal. Compounding interest is different. Compounding interest the interest is earned on the amount of money in the account. So the interest that you've earned previously is included in that. Now, the formula for compound interest is T equals P times 1 plus R over K to the KT, where T, once again, is the amount in the account, P is the principal, R is the interest rate, T is the number of years, and K equals the number of compoundings per year, meaning how many times you draw interest. So in this formula here, if we're doing it for 24 months, say T equals the principal, which is $100, times 1 plus the interest rate, which is 10%, times it's compounded monthly, so monthly is 12 times per year, raised to the 12 raised to the 12. Sorry about that, I had a little technical difficulties. Raised to the 12 times 2 for the number of years. So you substitute that in your calculator as it is, and you would get $110.47. That's how much it would be if it was compounded monthly. What if the interest was compounded daily? So daily means that K is equal to 365. So once again, you have your principal is 100. Your interest rate is 10%, but now it's compounded daily, so 365 raised to the 365 after 12 months, which is 1 year. And you substitute that in your calculator, and you get $110.52. Remember, your calculator is going to say, and we'll talk about this more, your calculator is going to say something like this. Remember, you round to the nearest cent, and with money, you're going to round up. So anything after that is going to round it up to $110.52. Compounded continuously. Compounded continuously means that it's compounded all the time or infinitely. If it's compounded continuously, this is where you're going to use E. So it's going to be A equals PE to the RT, where P is the principal, R is the rate, and T is the time, and A is the amount in the account. So basically the parentheses get replaced with the E, because as this K value becomes infinite, it basically goes towards E, which is 2.78. So if we do this compounded continuously with the principal is 100, the rate is 0.1, the time is 1 year, you substitute that in your calculator, you get 110.51700918, which when rounded is $110.52. Now notice when it's rounded, it's the same, but it's not exactly the same when you write it out, because continuously will happen more often than daily, but it's almost the same. All right, when we're solving a compound interest word problem, the way we're going to do it is we're first going to make let statements. X is going to equal what you are trying to find. And then y is going to equal the t value, which is the money in the account. And this to guide us in when we're using our calculator. Second, we're going to use a formula to write an equation. Third, we're going to come up with our y sub 1 or y sub 2 in our window. Then fourth, we're going to round. If our answer is in money, we're going to round up to the nearest cent. So if it's 0.2334, rounding up is going to make it 0.24 because anything after the second one causes us to round up. Time is rounded up according to how often the interest is compounded. Example, if the calculator gives us an answer of 3.6217 years and it's compounded quarterly, then we round to the nearest quarter, which would be 3.75. But remember, it's rounded up. So the nearest quarter from 0.62 would be 0.75. If it's compounded monthly, then we have to figure out 0.6217 times 12 months. That, if you do on your calculator, is approximately 7.4. So 0.6217 years is approximately 7.4 months, which rounded up gives us 3 years and 8 months. And then if you're compounded daily, 0.6217 times 365 days in a year, that gives you 226.9205 days. So rounded up, it becomes 3 years and 227 days. All right, so here's some actual word problems. The first one, remember our formula T equals P times 1 plus R over K to the KT. We know our principal is 650,000. We know our R is 0.0725. We know our K is 12 because it's compounded monthly. Our T is 11. Sorry, our time is 11, our small t. Our big T is what we don't know. So now, if we're solving for big T, then we do not need to solve graphically. If we're solving for big T, we can just substitute this in our calculator just like you see here, and it gives you an answer of 1,439,531.378, which rounds to 1,439,531.38. So if we're finding T, we don't solve graphically, big T, the amount in the account. The next one, notice the X is equal to the time, right? X is the time. So when we put this in our calculator, we have y sub 1 equals the principal, which is 4,700, times 1 plus 0.038 is our rate. It's compounded quarterly, so it's 4 times a year. And we're going to raise that to the 4x power, because x is our time. Our y sub 2 is the amount that's in the account, which is $10,000. Now our window, and this is where we have to think about our window, it's going to be from 0, and it's actually going to end up being 25, but you might have to play with it a while. And our other window, our other range, is 4,700 to 15,000.